students. All right, so today is a video that I'm going to be sharing with you on graphing your sine and cosine functions with a reflection. So what we have already talked about is, how we've got 3 different transformations that can be done. We did the dilation already. Okay, so multiplier outside, okay, that is a vertical dilation, changes the amplitude. Multiplier inside, that's a horizontal dilation that affects the period. And then when you have your period change, you want to make sure that you note what the new scaling will be, because again, there are 4 equal intervals. Okay, so here is what you should have in your notes, right? It's what each of the cycles looks like for y equals sine x and y equals cosine x when you rotate around the unit circle 1 time. All right, so this was the problem that you saw back up there, right? That we did in class on Tuesday. And now what we're going to do is we're going to take that graph, okay, and we're going to apply a reflection to it. Now, there's 2 different types of reflections that we could possibly go through. Okay, one is over the x-axis and one is over the y-axis. Now, the x-axis is going to be an easy one to do. Okay, so if you think about how your midline points right there, right on the x-axis, well, what happens when you reflect the graph over the x-axis and you've got points on the x-axis? They stay right on the x-axis. And then your minimums and your maximums, well, that's easy, okay? That actually just flips right over and becomes the opposite. Maximums become minimums and minimums become maximums. And it's the same way with the cosine graph, okay? Now, the reflection over the y-axis is a different story though, okay? So what we want to think about for each of these graphs is what does it look like if you extend the cycle to the left, okay? So that way we can envision what it would look like to reflect over the y-axis, okay? So that's the first thing I'm going to do, and I'll just do it very quickly down here, okay, is I'm going to do new set of axes, okay? I'm not actually going to bother putting the scaling or anything like that, because it's not really the point of what I'm doing here. All right, so we're just going to show what one cycle of sine looks like if I extend out in the positive x direction. Okay, so that's what that looks like. Okay, and now what does it look like if I extend out in the negative x direction? It would look like this. Okay, whereas for the cosine graph, what does one cycle look like? It looks like this. And what does one cycle look like if you extend out in the negative x direction? It looks like this. Okay, so anyways, what's important to note for each of them is what it would look like if you reflect over the y-axis. So I'm going to do this in a different color. Okay, so if you reflect this graph over the y-axis, then this maximum comes over here, right? And this minimum goes over here. And then, of course, this intercept stays right there, that intercept stays right there, and that intercept goes right there, and I connect those, and that's what that looks like. Okay, now if I take that cycle that's to the left of the y-axis and I reflect it over, then this minimum goes here, that maximum goes there, and then the intercepts go here, here, and here. All right, so anyway, okay, you know what that graph looks like, right? So what I've just done is I've reflected over the y-axis, right? This is your y equals sine x graph, right? But what does that actually look like you've done? Looks like you've reflected over the x-axis, right? So for the sine graph, that's actually what you want to do instead. If you have a reflection over the y-axis, why bother doing it over the y-axis? You would get exactly the same thing as if you reflected over the x-axis, okay? And it really wouldn't matter if you've already done a horizontal and a vertical dilation, because those maximums and minimums could be higher or lower, it doesn't matter, okay? Those x-intercepts could be stretched out further or coming closer, and that doesn't matter, okay? So really, why even bother ever reflecting over the y-axis for the sine graph? It's just harder. Just do its equivalent and reflect it over the x-axis. Now, why that is the case is because the sine function is a very special type of function, and that is that it is an odd function. So we've already talked about these types of functions earlier in the year, right? They are functions that have symmetry with respect to the origin. So if you look at the graph that's in the black, you can see that. Now what's going on when you reflect over the origin is you have all points x, y mapping to negative x, negative y. Well, if you think about the mapping for reflecting over the x-axis and mapping for reflecting over the y-axis, well, really doing one of each would just get you right back to where you started from, okay, with an odd function given that mapping. So therefore, you get the fact that for all odd functions, reflecting over the y-axis would produce the exact same graph as reflecting over the x-axis, okay? Now for the cosine function, right, so this is y equals cosine x, one cycle going in each direction. Well, if you reflect over the y-axis, basically, that maximum stays there, that maximum goes over here and vice versa, okay, this minimum goes over here and vice versa, and all these intercepts would stay, you know, flip-flop to where the other ones are, and you get the same exact graph, right? Why do you get the exact same graph? Is because there's symmetry with the y-axis. Well, why is there symmetry with the y-axis? Is because the cosine function is an even function, right? So of course, what do we know about even functions? We know that you can negate the x and you get back exactly the same graph. So if you're ever asked to reflect over the y-axis for the cosine function, don't even bother doing it. I mean, you'll realize as you're doing it that you're just mapping the function right back onto itself anyway. So it's kind of like a useless thing to do. All right, so that's important for you to know that about those two functions. All right, so pretty much what we want to just do is take the graph that we've already talked about here, and now what we want to do is give it a negation. All right, so we're going to take y equals 2 sine 3x that we've already done, and we're just going to put a negation out in front of it, okay? So that, you know, of course, we still have that dilation of 2 to the y's, which changes our amplitude to now being a value of 2, okay? We've got a dilation, okay, of 1/3 to the x's, all right, which is going to change our period, right, to being standard 2 pi times 1/3, which is 2 pi over 3, which then allows me to say, oh, well, I gotta change my scaling, okay, so I gotta take that period and divide it into 4 equal intervals. Well, what that really means is we gotta take 2 pi over 3 and multiply it by 1/4, which when we reduce down gives us pi over 6, right? So remember all that? Well, now we've got one more thing to talk about, and that is that negation, which is a reflection over the x-axis, because that negation is outside the parent function, so it will go over the x-axis, all right? So all I'm actually gonna do is I'm gonna go back up here to the cycle that we've already done before, okay? I would like you to actually make another sketch for yourself, though, okay? And I'll be a little bit lazy here and just use what I've already got there, but you make a new sketch of this, okay? And because I ran out of class time to do that second cycle, let's actually do it right now, okay? In fact, let's extend it out in the negative x direction. All right, so I'm just gonna go a little bit further out there. And then we would have 2 boxes going left, and that would be negative pi over 6. We'd have 2 more boxes. Oh, I'm gonna run out of room. Let me see. Let me sneak it in. Nope, I'm definitely not gonna be able to. All right, forget it. I will go out in positive x direction. All right, so 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. So this would be 5 pi over 6. This would be 6 pi over 6. Okay, and then let me just erase this. Oh, there's the bell. And extend that axis out a little further here. All right, and then we'd have 7 pi over 6, and then we have 8 pi over 6. Okay, and then we would just have our cycle continue on. Okay, so notice I had my midline point, which is where the cycle started, and then from there I just go to max, mid, min, and back up to the midline point. Okay, and notice how I just continue the scaling by pi over 6s. Okay, so 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6. Obviously, some of these can be reduced, right? Like this would reduce down to pi over 3. This could be reduced down to pi over 2. This could be reduced down to 2 pi over 3. And of course, right, that's the period. You don't have to circle it, but that was the period. 5 pi over 6 doesn't reduce. This reduces down to just pi. That's 7 pi over 6, that doesn't reduce. And 8 pi over 6 reduces down to 4 pi over 3. Well, and that makes sense, because if that's the second cycle, and we had our first cycle ending at 2 pi over 3, then our second cycle would end another 2 pi over 3 radians later, and that would be 4 pi over 3. And so now I am asking you to reflect over the x-axis. So as we did before, right, that just takes your maximums and changes them to minimums. Okay, just change your minimums up to maximums. And then your midline points, which are on the x-axis, okay, we're reflecting over the x-axis, wouldn't change those. So then you would get just that curve, there you go. And if I had given myself enough room, I totally could have extended in the negative x direction instead. All right, so hopefully you have understood the reflection over the x-axis well. Even if you were asked for the sine graph to reflect over the y-axis, had that negation been inside, you would have just reflected over the x-axis anyway, it'd be the same thing. And if it was a cosine graph and you were asked to reflect over the x-axis, hopefully you'd understand that. And if it was a cosine graph and you were asked to reflect over the y-axis, remember you wouldn't even do that because it wouldn't even make a difference. All right, hopefully you have a good time with the homework that follows. Bye.